10.3, 3D Trig. So a couple of review problems you can try. This one's terrific. You get a flagpole and a non-right triangle problem practice. Got the answers here. Then there's two problems here. This is similar to that last one, and then a tower problem. And this tower problem you're going to be able to do after today. And the answers are all worked out on this one. So first thing I'm going to do before we do any 3D trig is we're going to talk about how you draw something in 3D. And almost everything starts with a parallelogram. So if you take two parallelograms and you stack them up and you put all of these here, and well, this won't let me do much here. Like that, you've got yourself a cube. If you want a pyramid, all you have to do is take some straight lines, start with a parallelogram, and then go to each spot, and you've got yourself a pyramid. For a wedge, what you'll do is you'll take each place here and here, and then make that parallelogram like so. And now you've got yourself a wedge. And that angle, you could say, is an angle theta, the angle in which that wedge is. You can describe all kinds of different angles, as we'll see in a little bit. Sometimes a problem will, like the tower problems, will ask you to go into 3 dimensions. And I want to emphasize again the parallelogram. If you have a parallelogram, draw a vertical pole and then make a little compass, north, south, east, west, but don't make them like you're used to. Because the parallelogram is faking 3 dimensions, we're going to fake that north, south, east, west the same way. So let's say that somebody walks, let's say they go west so many feet, and then they go south so many feet. Now, that doesn't look like west and southwest, maybe, but south, no. And what you might be interested in is what is the angle between this point and the top of the pole and the bottom of the pole. And you might be saying, oh boy, that's it's pretty hard to visualize. Probably that angle is, but let's say I went, let's go the other way and try going east, and then we'll go north, like this. Now, if you're looking at an angle from this point and this point, okay, now you've got an angle of, let's say, 48 degrees, and then this one is going to be a little more. This one's further away, this one's closer, so it's probably going to be closer to like 62 degrees. Here and here. Now this is both the ground, and then maybe when you went east, you went, maybe 100 meters, and maybe you went 70 meters this way. Well, now you're able to describe a 3-dimensional situation where now you can talk about what the height is because you have some means of doing that. Well, this one would be silly because if they gave you this 100 meters and 62, you could find the height easy. But if they didn't give you this and they gave you these two, now you've got an interesting problem. And that is exactly what we're going to be working on one of these days. So just to give you a hint on some of these before I assign them, here's cubes, and they have them tilted, little planes tilted inside. So when you do problems like this, try to reduce them to simple triangles. Like this one, because it's tilted the same way, you can think of both of these triangles as the same, because they both have 12 centimeters. They're both going to be, if this whole thing is 16 and this is 6, this will be 10 centimeters, 10 centimeters. You can see it won't matter if you're looking for this angle theta if you do the front one or the back one. But if you do something like this, these angles are going to be very different. This, because these, this side and this side, the angle of this triangle is, the planar angle is not this angle. It's a little different. It's from the center here to the center here. So I'm going to do this with a little bit better equipment here. We'll go from center to there, center to here, and then now you can figure out what this angle theta is. And you would need to know what this length here is, or you need to know what this length is. I don't think you need to know that second one, just need the first one because you have a height of 6. If you knew this length and you knew the 6, you could find that angle theta. And I'll let you look at that one. This wedge, I'll let you think about it. Just remember with a wedge, you're talking that there's it's implied that these are 90 degrees. Lots and lots of 90 degrees. Square, rectangular pieces that are form 90 degree angles, and that'll help you find those. On this second day, got some more of those working within a 3D structure. Here's where we get the tower puzzle, the tower problem. A tower has been constructed on a bank of a long, straight river. So what we'll do first is we'll make our little parallelogram, like I mentioned. Parallelogram. Parallelogram. There we go. That. And then here's the pole going up like this, tower. I like to put 2 of these so it looks like a tower. And then it says, we're on the banks of a river. There's my river. Okay. And let's see, the tower is constructed on the bank of a river from a bench on the opposite side, and 50 meters downstream. Okay, so here's my river, and they're saying that they are 50 meters downstream. So from here, 50 meters, and then it's across the river like this to the other side. The angle of elevation of the top of the tower is 30 degrees. From a second bench on the same side of the tower and 100 meters upstream, find the angle of elevation, and the angle of elevation of the top is 200. So on this side, this is going to be kind of easy, this part. This angle of the elevation is going to be 20 degrees. So this is 20 degrees. Ooh, fun. Let's cancel that. And we'll just go 20. Oh, it's still doing that. That's weird. Why that's doing that. 20 degrees. And then this was 100 meters upstream. And this was 50 meters downstream. And then when we crossed the river, we had an interesting thing. We had an angle from the bottom to the top that angle was 30. Okay? 30 degrees. Okay. So we want to find the height of the tower and the width of the river. So here's kind of what I would think is that you have two triangles. One triangle is this yellow one. And then the other triangle is this one here. There's a third triangle, and that third triangle is kind of distorted here, but it's in this little space here that's 50 meters, and down here it's this little triangle down here. Now it's kind of a hard one to see, and it's a hard one to imagine, but it's really a right triangle. This is going to be 50 meters, and this is the distance that we're looking for of the river. Now you might say, well, this is unsolvable because I don't know any of these two angles. They know the angle of this green one, but I don't know the angle of this down here of either corner of that purple. But as it turns out, all of this is solvable, and I'm not going to solve it for you. I'm going to set it up. We're going to find the height of the tower first. Height of the tower is going to use the yellow triangle. And this is 100 meters, this is 20 degrees, and this is the height. So if it's a right triangle, the tangent of 20 is h over 100. Or we can just say h is 100 times the tangent of 20. Okay? I'm going to leave it this way just because it's a little easier for me. Then I'm going to take the green triangle. Now the green triangle in 3D, hard to see, but the green triangle has a height of h. It has an angle of 30. And if we knew this distance x, hard to evaluate, kind of hard to see, but that's this distance here. And if you knew this distance x and 50, you could use Pythagorean theorem to figure out d. So, the tangent of 30 is h over x, and we said h. I'm going to replace h right now. Well, something interesting happened. My entire screen just blinked out and we lost the whole file. But remember, on the one triangle, we had the tangent. This was 20. This was h. This was 100. So we said h was 100 times the tangent of 20. And then on the other triangle, this one here, that is a right angle. This is 30. This is still h. And we want to find x. The tangent of 30 was h, which is 100 times the tangent of 20 over x. So x is going to be 100 times the tangent of 20 over the tangent of 30. Once you have this x, then that's the hypotenuse of this base triangle, which has the distance across the river, has 50 meters given, and then you calculate this x, which is 100 tangent of 20 over tangent of 30. By the way, tangent of 30 is 1 over the square root of 3. You probably remember that. So anyway, then all that you do is you take this squared plus this squared equals this squared. Distance of the river squared plus 50 squared equals 100 tan 20 over tan 30 quantity squared. And then you can solve for D. And that'll be your distance across the river. So in part A, you're going to take 100 times the tangent of 20. In B, you're going to take D squared, and you're going to take 100 tan 20 over tan 30 squared minus 50 squared. And then you'll take the square root. And that will be the distance across the river. That's pretty cool. So there's your 3D tower. If you go back, I had some practice problems for you. Here's a tower problem that you can draw and figure out, and all the answers worked out. You can work on some practice problems. There's some more slant wedge problems. Here's a list of all of the topics that are that are possible for your test. Remember, you're doing 3 chapters, so for this chapter, we'll have solving triangles, 3D dimension, like your tower problems, a bearing problem, a lamp problem. The formulas you need to know are just the basics, SOHCAHTOA, Pythagorean, know how to calculate with the DMS, and those special triangles. If this is 60 and this is 30, the smallest side, if that's x, the hypotenuse will be 2x, and the longest side will be x times the square root of 3. If you have a 45, 45, if this is x and this is x, this will be x square root of 2. You can divide everything by square root of 2, and you'll get x over square root of 2, x over square root of 2, and you can do the same thing with this one, with the 30, 60, 90, divide by 2, divide by square root of 3, you can do whatever you want to get all those combinations. So that's what the test is. Now I do have more practice for you. These are chapter 10 practice that we worked on. I would highly recommend that you take a look at them. The answers are provided at the end, and they're worked out. So that would be your review for chapter 10.